Hey guys, hello everyone. This is Nurul Huda and I am a verified educator at an online learning platform that is an academy. You can access my videos over there as well. So if you're preparing for CSIR NET, GATE or IIT JAM, any of these exams, you can access my videos over there as well. These are going to be very helpful in your preparation, right? So in order to access my videos, what you have to do, you have to download this Unacademy Learning app and you can search for my name, that is Nurul Huda, or you can go directly to my profile from the link given in the description. That's all for this. Let's continue with the video. Yes, hello everyone and welcome to the channel. So in this particular video we are going to talk about questions of your part C. Basically I'll be talking about physical chemistry questions. I'll be solving few questions in a brief and I'll be telling you answers of most of them. Whatever I have appeared, like whatever I have done in the exam, and some of them also are there which I haven't done in the exam but I came to know after coming. Okay, so those questions, those things I'm going to share with you all, and I'll be telling you some solutions in very brief, and in the detailed solution I'll be posting on an academy soon, right? So I'm working on it and that will be uploaded like in 1 or 2 days. So yeah, so let's talk about the first one. Over here you can see that this question over here, it says that one of the Huckel molecular orbital for 1,3-butadiene is given to you. So you have these things. So now by looking into this equation, the Huckel molecular orbital, you can find out that whether your orbital will be like how much nodes you have. Okay, so how to find it out? So if you have your, like, if I draw it like this, if I have uh, an orbital like this, then yeah, so if you draw your orbitals, so it will be like this. Okay, so I'm just trying to make you guys understand this thing. So yeah, that will be a smaller one, then a smaller one, and then a bigger one. Okay, so if let's say this is the positive lobe, so this will also be the positive lobe, and then it will be your positive side will be downside, because this is the node, right? So this point is the node. So you are going to get like plus plus minus minus. So two terms will be positive and other two will be negative. So that's how you can see that this is having how much nodes. So you are having one node over here. Okay, so that's how you can understand. Okay, for zero node, how it would look if you don't have any node. So that lobe will, like, that wave function will look something like this, and over there you will be having orbitals or the lobes something like this. Okay, so they will be something like this. Yeah, so you will be having like plus plus, so all will be plus over here. Okay, so both all will be plus 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 plus. So this is how you can understand that like how much nodes you are have you will be having. So over here for this particular question you have one node. Now for one node, what will the energy value? So if you draw the energy value, I'm just doing it over here. So if you have these four energy levels, so the lowest one is how much? It is 1 plus 1.62 beta, right? Sorry, alpha plus like alpha plus 1.62 beta, then you have alpha plus 0.62 beta, then you have alpha minus 0.62 beta, and then alpha minus 1.62 beta. So I can give all the detailed data also, but that I am going to post on an academy. So this is what how it is to be done. Okay, so now one node, how much node for this? For the first energy level you have zero node, then one node, then two node, and three node. That is what you have also studied in your pericyclic chemistry as well. So one node is present in this one, this one. So the energy for this, the value for this will be, the energy of this particular orbital will be alpha plus 0.62 beta. So this will be the correct answer for this. Okay, so that's how it has to be done. Now let's talk about the next one, where it says that the molecule AB2 shows following IR and Raman spectra. So yeah, so if we talk about this particular one, so this question was directly asked from your KL Kapoor. So if you have KL Kapoor, this question was directly asked. So how it is to be done? See, let's take an example of some molecule. Like let's say we have a molecule, let's say A, B, and C. Some molecule, some a linear molecule. So if you do symmetrical stretching, then PR will show. Okay, so this will be PR. That means your linear molecule is linear. So if you have PR, then it means this is linear. Okay, so here also it says that it is linear. So this is basically this basically tells you about symmetrical stretching. This tells you about asymmetrical stretching, and this tells you about bending. So if you do bending, then linearity is lost, so it is non-linear over here, so it becomes non-linear. So when Q comes, it becomes non-linear. So which of these will be like asymmetrical? That means it is not a symmetrical molecule. If all would have given linear, then the molecule would have been would have been linear and symmetrical. So linear and symmetrical molecules have like linear and symmetrical molecules generally have d infinite h as their point group. So this is not the case over here. This is linear. Over here your molecule is linear and asymmetrical. Okay, so if you look at the KL Kapoor book, over there this particular, this same, exactly same thing, exactly same data has been given to you in example of N2O. So basically two questions were asked directly from here, one in 2 marks where they were asking about the point group of N2O, and the second one over here for 4 marks. So KL Kapoor 4 and 2, that is 6 marks has been came from there directly. Okay, so the correct option, so for a for a linear asymmetrical molecule, your point group becomes linear asymmetrical, that is C infinite V. Okay, so that's how you can do this particular question, right? Now 115, for this one it says that for a one dimension harmonic oscillator perturbed in x cube potential, the sum of first order and second order correction of the ground state energy is. So it's pretty simple. If you have read perturbation theory, if you know the postulates also, then also you would have done this question, because the first perturbation, the first, okay, so the first perturbation is 0. Okay, so first perturbation is equals to 0, whereas your second perturbation is equals to negative. So that means if you sum both of them, you are absolutely going to get a negative term that is less than 0. Okay, so that this is the correct option for this. Right, so let's talk about the next one that is also from your quantum mechanics. So 116, it says that the difference of energy values of position for a state n is equals to 1 and n is equals to 2 of a particle confined in one dimensional box of length L is. So you all know that your psi for one dimension box is given by nothing but your 2 by L, and then you have sine n pi x by L. Okay, so this is how your psi is denoted. Okay, so for a particle in one dimensional box. Now we know that the average value of x is calculated by this formula, that is minus a to a psi star x, okay, then psi and dx. Now if you solve it out, that means it doesn't depends like if you will solve it out for a one dimensional box, what I have done, I'm not going to solve it, I'm just going to tell you that for a one dimension box, if you solve this average value of position, you are going to get how much? You are going to get L by 2. Okay, so that's what you are going to get, but this L by 2 doesn't depend on n. Okay, so whether it will be n is equals to 1, n is equals to 2, or any of these, it will be always L by 2. Now they are asking difference for it, so for n is equals to 1 also you will be getting L by 2, for n is equals to 2 also you are going to get L by 2. If you take difference of them, you are going to get 0. So 0 is your correct option for this particular question, right? Okay, so let's talk about this one over here. It says that the third and the fourth line of rotational Raman spectrum of CO is separated by 8 centimeter inverse. The CO bond length is given by, so the answer should be this one. I will not explain this right now over here. So this answer should be like h upon 16 pi square mu c, and this is what I think, and if you have any doubt you can tell me. Okay, so talking about this one, the phase transition between incompressible phases. So I'm not sure about this particular question. I'm not at all sure about it. I have just marked this question. I have just marked it because I thought that I have read somewhere that the entropy of such transition is 0, but I'm not sure about it. Okay, so if you guys know answer of this particular question, you can share with me in the comment section. I don't have any idea about it. I have to read some book for regarding this. Okay, now talking about 118, it says that the transitional partition function of AR confined to volume 1 liter is 3 at 300 Kelvin, having thermal wavelength of this 1.6 into 10 to the power minus 11 meter is closest to. So in order to calculate this, the transitional partition function is given by V upon lambda cube. So where V is the volume, lambda cube is the thermal wavelength which you use. Now the volume over here is in liter and this is in meter, so you have to convert it. So you all know that what your like 1 liter is equals to how much meter. Okay, so just convert it into liter into meter cube, and then your meter cube, the wavelength is already given in you into. Okay, so just solve it out, and if you solve with them, you are going to get like something around this, that is 2.44. That's what I have solved, and I got it. So 10 to the power 29, so 2.44 into 10 to the power 29, that's what you are going to get for this particular question. Right, so these were the questions on this particular page, and yeah, one more is left from quantum, and that is for the Hermitian operator. This was the easiest one. Okay, so over here you have different options, but this operator is your momentum operator. So momentum operator is Hermitian, you all know. So just if you have practiced questions regarding your basics of your Hermitian operator, then only you would have done this question. And also in my video, where the video which I made on Hermitian operator, if you have watched that video, I have explained these things. Okay, so this momentum operator I have done over there as well. So this question was pretty simple. Just by looking into it, you could have got like 4 marks. So that's why I'm saying that question paper was easy, because see, these questions you don't have to do much, you don't have to know much. If you know the basics, if you have read them, you could have done these questions easily. Okay, so let's talk about the other questions as well. So let's talk about this question. Over here, it says the conductivity of water and saturated solution of a sparingly soluble salt of AB2 are like 7 and 21 microsiemens per meter, and given that your lambda naught A2 plus and lambda naught B minus is given to you in these values. Okay, so first of all, you have to use Kohlroas law, that is your lambda naught of your AB2, that will be equal to lambda naught of your A2 plus twice of your lambda naught of uh, like B minus. Okay, so now just put them out and solve it out, so you are going to get 28 something. Okay, so 28 is what you are going to get over here. Now the solubility, what they are asking is the solubility. Okay, so the solubility is given by this formula, that is kappa of your AB2, that is your sparingly soluble salt, minus kappa of your like kappa of water. Kappa is nothing but the conductivity, and divided by your molar conductivity. Okay, so molar conductivity, that is what your lambda is. Okay, so this is what your molar conductivity is. So in the numerator you are going to get around yeah, so it's given 21 minus 7 divided by 28. So if you will solve the numerator, you are going to get how much? Yeah, so in the numerator you are going to get 14 and divided by 28, and this is what. So in the numerator the values are in microsiemen, and over here you have millisiemen. So just convert microsiemen into millisiemen, so that will you have to multiply it with 10 to the power minus 3. So it will be 14 into 10 to the power minus 3 and divided by 28. So it will be like 1 by 5 into 10 to the power minus 3. So that will, sorry, 1 by 2 into 10 to the power minus 3, and that will give you 0 0.5 into 10 to the power minus 3, or you can write it as 5.0 into 10 to the power minus 4. So like that your, oh sorry, not this one, yeah, so first one is your correct option. Okay, so that's how you have to do. Now the next one, the equilibrium constant question. It was pretty simple question, very easy, although some calculation mistake I have done. I have recalculated, and it will come option number 3 for this. So the equation which you are going to use is this one, that is E is equals to 0.059 upon n log keq. Okay, so where keq is your equilibrium constant. So try to do it correctly. I think I have done some calculation mistake, because I found out that many of the students have done this, and that's why I'm thinking that I have done it wrong. I didn't like did it properly twice also. So I'll just ask you guys to solve it out. Solve this 102 and tell me that what is the answer. Is it option 1 or 3? Okay. Yeah, so now this question, this was straight from my special class or from any of my class, like say like few like 1 week before the exam I posted that video on surface chemistry. And this is the thing which I always like I emphasized on in that particular video, that whenever you have dissociative or associative adsorption, in that case only this power will change. Okay, and that's what somebody asked me in the comment section also. If you go to that video and watch, those comments, many of the students asked me that why for O2 also you are not, like, if O2 is getting absorbed, okay, so if O2 is getting absorbed, because it was a certain question from the previous year, so they were asking that why O2 is getting absorbed and then you are not putting 1 by 2 over there. So for them I told that, see, O2 is getting absorbed but O2 is not getting dissociated. Okay, so unless and until you have dissociative absorption, you don't have to put this power. Okay, so since it is mentioned in the question over here that it is a dissociative absorption, then only I have taken the power to be 1 by 2, and that's why the correct option will be option number 3. So I hope that most of you like did this question correctly, and I hope that my videos helped you guys. Okay, so yeah, so let's talk about the next one, the entropy of the perfect gas. Now this was also pretty simple question, although see if you can see this part of the screen, which is the screen, like, which is the part of my question paper. So I have solved all these things over there only. So if you solve it out, it will become like your like S will be equal to your RT ln V, something like that. Okay, so if you solve it out, it will you will get to know that it is proportional to your log V. Okay, so I'll solve this in detail on my Unacademy profile, so don't worry about it. So till now, just take it out that the correct option is your option number 3, right? Let's take the other left out questions as well. Let's talk about this question. That was your question number 105, and it says that the contour and the root mean square length in nanometer of the polymer chain modeled as random coil with n is equals to 1000 and L is equals to 150 picometer. So basically this is given in picometer and they have asked in nanometer, so you should be very careful about the units over here. So the formula was very simple, the formula was very direct. If you have read this topic from your polymer chemistry, although these topics are not that important from examination point of view and they have not been asked in the last 3-4 years, but this time they have asked, and if you have read some book, then only you would have done this question. Okay, so the contour length is given by, like, the contour length is given by this formula, that is n into L, and your root mean square will length, that is root mean square length is given by this formula, that is under root n into L. Okay, so just put them out and solve them. Be very careful that you have to put L is equals to like your L should be your in nanometer. Okay, so just convert. So 150 picometer in nanometer will become 150 into 10 to the power minus 3 nanometer. Okay, so just put it like that and try to solve it out. So I'm leaving this for you. Okay, so I'm not solving it. Yeah, so the next one, this is pretty simple, just put in this formula and you will get. Okay, so let's talk about 106. Over here it says that the free energy and of a system with 10 non-interacting spins. Okay, so you have 10 non-interacting spins and you have to tell like you have actually bosons, because the spin is given to you as 1, so you'll consider them as bosons. I have told you about this, like fermions and bosons, so that doesn't make very like difference, but the formula you will use over here is this, that is dou A by dou T at constant V is equals to minus S. Using this formula you will derive an equation, like when you integrate it over here and you will solve. So what you are going to get is this, that S is equals to KB KB ln 10 to the 3 to the power 10. Okay, so this is what you are going to get. So when you solve it out and you will get it out, so you will get how much that will be. Like if you solve and put and like do, then A value will come out to be like minus 10 T KB ln 3. Okay, so this is what the answer should be. I will post the detailed answer on the Unacademy profile. Okay, so the correct option will be minus 10. Yeah, so option number 2 will be your correct option. Now the next questions from the group theory, they were quite different kind of questions from group theory, but they were very easily approachable. If you know character table and if you know the properties of it, you would have done this question easily. So talking about this 107, question number 107, the correct option for this question will be your B3U. Okay, I will post the detailed explanation on the Unacademy profile for this. 108 was also very easy question. So it says like B1U to B2G. So B1U you are doing from like from B1U to B2G. Okay, so you are going from here to, like, yeah, so you are going from here to here. Okay, so now they are asking which polarized light it will be. so it will be Z polarized. Okay, so the correct option will be allowed by Z polarized. So using the table you can do that question. Now talking about this metal crystal, so use this formula only, like 2d sine theta is equals to n lambda. Using this formula only, that just you have to square and put value of d as a upon under root h square plus k square plus l square. Put any of these at the place of that, and any of these like sine square theta. Okay, so just keep on, like if you are putting hkl as this, then you have to put sine square theta as this, and you will get the answer. So the correct option for this is your, so you will get correct option as option number 3 for that particular question. Okay, now let's talk about this one, which was not directly from Michaelis-Menten equation but from the Lindemann equation. Okay, so from your so from your Lindemann equation, this question was asked from your enzyme catalysis, and the equation is given by this, that is K uni is equals to K2 into K1 into concentration of M divided by K minus 1 into M plus K2. So this is the equation. If you like if you change it out, like if you take reciprocal of it, so 1 by K uni is equals to K minus 1 into M plus K2 upon like K2 K1 M. Okay, so I've just taken reciprocal of this particular question, like this particular equation. Now over here you will get, like if you divide it separately, so you are going to get K minus 1 upon K2 K1 and plus 1 by K1 M. Okay, so you are plotting graph between this particular thing and this particular thing, right? So this will equal to y is equals to, this will become M, X and C. So M, that means slope will be 1 by K1. So 1 by K1 will be nothing but the slope, that is 4 into 10 to the power 6, and intercept will be 8 into 10 to the power 11. So intercept is this much, but you just need to find out the value of K minus 1 upon K2. So you just put the value of, like, so the intercept, I am just solving it over here. So K minus 1 upon K2 into K1 is equals to how much? 8 into 10 to the power 11, and 1 by K1 is your slope, so that is like K minus 1 upon K2 into 4 into 10 to the power 6 is equals to 8 into 10 to the power 11. So your, yeah, so I'll just need some space to solve, so just write it over here. So K minus 1 by K2 will be equal to 8 by 4 into 10 to the power 11 minus 6, so that will be around 2 into 10 to the power 5. So your correct option is your option number 1. Okay, so that is how you have to do. The next one is your decomposition of mechanism of ozone. So I think that this question should be first order, and that's what I have discussed also with others, and they also said I'll post the detailed answer very soon. So first, the correct option will be option number 1. And last question from your physical chemistry. So your physical chemistry, sorry, for this question basically you can use that thing, the bond order, and the bond order will tell you the order of your fundamental vibration frequency. So the bond order for O2 2 minus is 2.5, then for this it's 2.0, and for O2 it's 1.5, and then for O2 plus it's 1.0. So the decreasing order of, sorry, I've just written it down. Okay, so as your yeah, so as your wait, so basically the order is reverse of it. So for O2 2 minus you have 1.0, for O2 minus you have 1.5, for O2 you have 2, and for O2 plus you have 2.5. So as soon as as your bond order increases, your vibrational frequency also increases. So this is what the concept is behind this particular question. So that's all for this video. I have taken these questions. I hope that I have covered all the questions of your like part C. Few of them are left out, so I'm trying to solve them out and tell you guys as soon as possible. I'll try to post these all the questions in a detailed way on my Unacademy profile. So see you guys over there, and thank you so much for watching, and tell me in the comment section that what are the doubts, what you like in this video, and what are the things you want to ask. Okay, so that's all for this video. If you are new to this channel, you have to subscribe this channel, okay, because I keep on posting videos for you, and you can give a like to it. If you are new to this channel or old to this channel, you can give like to any of my videos and share with your friends, because sharing is caring, right? So I'll see you guys in the next video. Till then, have a great day. Bye bye. Take care.